We continue to look at an example to find the equation of plane through 3 points A, B, and C in vector form and also in Cartesian form. So in order to find the equation of a plane in vector form, we need 2 vectors on the plane. I can have a diagram. I can have a sketch for points A, B, C on a plane. Let's say A is here, -1, 2, 0, B, 3, 1, 1, and C, 1, 0, 3. So our next step, in order to form the equation of a plane in vector form, we need a fixed point plus lambda of a vector on the plane, and also mu plus another vector on the plane. If I choose to do AB from A to B, a vector from A to B, the direction vector from A to B, another is the direction vector from A to C. So we need to find each of the direction vector first before we can write the equation of a plane. So AB, using the position vector of A and the position vector of B, it is OB minus OA. Because we know their coordinates, so OB 3, 1, 1 minus OA is -1, 2, and 0. And therefore, the vector AB is 4, which is using 3 minus -1. So minus negative become plus. Similarly, 1 minus 2, -1, and 1. So this is the direction vector of AB. Similarly, the direction vector of AC is using the position vector of C minus the position vector of A. So OC minus OA. That is 1, 0, 3 minus -1, 2, and 0. And then you will get 2, -2, and 3. So the equation of the plane in vector form, is represented by x, y, z equals to -1, 2, 0. The fixed point that I'm using here is point A, plus lambda followed by AB for -1, 1 and mu of 2, -2 and 3. Alternatively, we can represent the equation of the plane in Cartesian form, but in Cartesian form we need to find the normal. So normal of the plane is AB cross AC. Since I have AB and AC, so I cross the two direction vector, I will get the normal to the plane. So in order to find the normal, AB for -1, 1 cross 2, -2 and 3. So we are going to find the determinant of the matrix here. Row 1 is IJK, row 2 is vector AB for -1, 1, and row 3 is 2, -2 and 3, which is our vector AC. And this is equals to I, the determinant of 2 by 2 matrix, where we tend to delete the first row, first column, and you will see -1, 1, -2, 3. You have to put it into here. Followed by -j, the determinant of the matrix, by deleting row 1 and column 2. So 4, 2 and 1, 3 must be the determinant of the 2 by 2 matrix here. Plus k of the determinant of the matrix by deleting first row, third column, and 4, -1, 2 and -2 must get into this matrix. And that you will get cross product of two vectors, you will get another vector. So you will have, if you are not familiar with how to find this, I'll show you one more time here. We multiply -1 and 3, that's -3. Then we multiply 1 and -2, that's -2. Then we use -3 minus -2, that we will get -1. The I component is -1. So similarly, we multiply 4 and 3, so 12. We multiply 2 and 1, so 2. So we take 12 minus 2, that's 10. But it is a -10j. So the answer for j component is -10. So similarly, you find the determinant of this matrix, okay, -8, -2. So -8 minus -2, they will get -6. So the normal to the plane is -1, -10, and -6. So in order to find the equation of the plane using normal, which we call the Cartesian equation or the Cartesian form of a plane, we have xyz dot the normal equals to a fixed point dot the normal. And I have been using vector AB, vector AC, so our fixed point over here is OA. And the Cartesian form xyz dot our normal is -1, -10, -6 equals to OA -1, 2, and 0, -1, 2, and 0 dot the normal -1, -10, and -6. Then you will get -x, -10y, -6z. When we do the dot product, we multiply the x and the -1, then we get -x. So similarly, you multiply y and the -10, you will get -10y. So the right hand side, which is -1 times -1, so you get 1, plus 2 times -10, so you have -20, plus a 0. So then you have -x minus 10y minus 6z equals to -19. And you can leave your answer in this form is totally correct. Or you can actually, because all the terms over here, they are negative, it is also the same as x plus 10y plus 6z equals to 19. And this is the Cartesian equation of a plane.